All right, first we want to remind ourselves that soluble ionic compounds dissociate into ions when dissolved in water. These ions are held into a crystal lattice structure in the solid state, but once they're placed in water, these ions go their separate way. And there's a reminder here that polyatomic ions stay together in these dissociation reactions. So you want to be able to recognize our polyatomic ions. So if we look here, we see we have a phosphate, nitrates, carbonates, sulfates, and hydroxides. So keep in mind those polyatomic ions are going to stay together as a unit. One other reminder is that almost all metal cations are monatomic. They exist as only one atom that has a charge on it. They're monatomic. All right, so if we're looking at each of these dissociation reactions, what happens when we add water? These are all soluble ionic compounds. You can confirm that by looking at our solubility rules. All right, and here we go. In this first problem, potassium phosphate, we see we have 3 potassium ions and a phosphate ion. So it's going to be 3K plus aqueous plus that phosphate, PO4 3 minus aqueous, and it stays together in solution. Again, this is almost all the metal cations are going to be monatomic, so these are 3 separate potassium 1 plus ions and a phosphate ion. Overall, in this dissociation, we have 4 separate ions. Okay, looking at the next compound, copper 2 nitrate, we see that we're going to have a copper 2 plus ion. We know it's a 2 plus ion because there are 2 nitrate ions, and each one is a -1. This is why we memorize our polyatomic ions, the formula, the name, and the charge. So we have 1 copper 2 plus ion, 2 nitrate ions, and therefore we have 3 separate ions from each unit of copper nitrate. Looking at sodium carbonate, we have 2 sodium plus ions and a carbonate ion. For 3 separate ions from each formula unit of sodium carbonate. Iron 3 sulfate. A little bit more complicated. We have 2 iron ions. Let's leave their charge for now. We know that there's 3 sulfates. If we have 3 sulfates, there's a net -3 that has to be balanced out by the 2 iron ions. So therefore, each iron ion has to be a 3 plus ion. So in this situation, we have 5 separate ions that are released in solution for each unit of iron 3 sulfate. Magnesium hydroxide, when it dissolves, it's not super soluble, but when it dissolves, it's going to give an Mg2 plus ion and 2 hydroxide ions. And that, therefore, for this compound, we have 3 separate ions that are released in solution for each unit of this compound.